Numbers are one of the most often used type of variables. Be it for the storing of temperatures, ages, or other information, most programs will contain any kind of numerical data. Generally, different types of numbers can be distinguished. The first basic type is the so-called integer, called int in Python. This can capture whole numbers, positive and negative ones, and zero. In Python 3, there is no limitation of the size, thus we do not have to take care of that aspect. Examples could be ages or temperature without decimals. A type for storing more precise numerical values is the floating point, called float in Python. It can capture numbers with decimal points, both positive and negative. Examples can be grades for students or more precise temperature information. The type complex can store imaginary numbers, which are built up by two floating point numbers a and b, and the imaginary unit j, which is the square root of -1. Here we can see how an imaginary number is defined. Floating point numbers can be represented by scientific notation as well. This is especially useful for very large and very small numbers. The representation consists of the significand, the letter e showing the basis of 10, and the exponent. Examples can be large weights or very small errors. Correct naming of variables is very important in programming. But why do we even need variables? Can't we just write the required values into the code? This would be a naive approach for the output of data, which is called hard coding, where the values are directly written into the code. In that case, the code has to be edited if the values change. And that means at all places in the code where that value occurs. This is of course very inconvenient. Instead of that, values are stored in variables, which can be described as storages for values. Now, instead of changing all parts of the code where the value occurs, we only have to change the value of the variable. It only has to be defined once and can be put anywhere as a kind of placeholder. Three aspects have to be considered when naming variables. The first one is that there are so-called reserved words that cannot be used, such as print, def, or if. These are words used for the Python functionality and that cannot be reused as variables. The second aspect is that there are certain Python naming rules, thus fixed rules that have to be held for a variable to be valid. A variable, for example, has to start with either a letter or an underscore. Furthermore, after the first character, variable names can consist only of letters, numbers, and underscores. The third aspect captures so-called coding standards, thus standards of the community which are best practice conventions. Variables should be lowercase with words separated by underscores to be conventional. The following table shows valid, invalid, conventional, and unconventional variables. The red variable, for example, is invalid because it does not start with an underscore or a letter, and also unconventional because it is not lowercase with words separated by underscores. The yellow variable is valid because it consists only of letters, but unconventional because it is not lowercase. The green variable is valid and conventional because it holds both the Python rules and the conventions.
Data structures: list, tuple, set, and frozen set. In addition to strings, very often used data structures in Python are lists, tuples, set, and frozen sets. An example of these data types is given to the right of this slide. In the input cell number 1, you see the definition of a list, my list. This list is defined using the values 5, 4, 3, D, C, B, and C again. In addition to this list, my tuple is defined, containing the same elements, but being a tuple. This is identified by the different shapes of the parentheses. In the third line of input cell number 1, a set is defined, containing again the same elements. And in the last line of input cell number 1, a frozen set is defined based of the previously defined set. These 4 elements are printed out in the input cell number 2. As you see, the list contains the defined elements, also in the same order as we defined it. Very similar it is in the case of the tuple, my tuple. Also, all elements are still included and the order is kept. However, in case of my set, differences have appeared. On the one hand, the order of the elements has been changed automatically within Python. Furthermore, duplicated element C is removed, so that only one element being C is contained in my set. Very similar it behaves in case of the frozen set. In programming, the shown data structures can be very helpful. However, they distinguish in terms of different aspects. Some of these elements provide the opportunity to add additional elements into it, while other does not. Some keep the order in cases which it might be useful, and some do not consider the order or forget duplicates. In addition to the order, you can access some elements by using the index or the position of those elements. For example, to iterate through a list or to access a certain position within a list. So in summary, there are plenty of methods you can apply to these data structures. On this slide, an overview of some certain aspects of these elements is given. Whether they are mutable or immutable, whether they keep the defined order or not, is indexing or slicing possible, or can duplicated elements be contained? Being mutable or unmutable is very important regarding the speed of your program. This aspect will be shown in one of the following videos. File sampling. In this presentation, you will learn how you can perform important operations with files. Files are an easy but still frequently used method to save data digitally. Compared to databases or cloud storages, the data can be accessed easily, is well transportable, and can be used offline. Python offers easy methods to interact with files. We will subsequently get to know the basic methods. You can open a file with the open command. The open command takes 2 arguments, the path to the file and the access mode required. For the access mode, we have the four options: read, write, append, or create if not exist. Therefore, we use the letters R, W, A, R, X. Reading the content of files can be done line by line using the read command, or at once using read lines. While in writing mode, you can write to the file using the write command, which takes the text you want to write to the file as its argument. It is important to close the file after using it, using the close method, or using the open file method in the context manager. To the right of this slide, we will see some examples. In row 1 of the first input screen, you can see how a file gets opened with reading access. It then undergoes a line-by-line readout via a for loop in row 2 and 3. To remove any unwanted letters, the strip command is used before printing it out line by line. Finally, in row number 4 in input cell 1, the file is closed, which is very important. In input cell number 2, a file is opened, but instead reading it out line by line, the whole content of the file is read out at once using the readlines method. After readlines method, the file is closed. In row number 4 and 5, the content is printed out. In input cell number 3, another approach is shown using a context manager. You can open a file within a context as it's shown. Then again, you have the possibility to access the file in different modes. Mutable and immutable data types. Different data types also differ in terms of their capabilities to be modified after they have been initialized. Therefore, the two following categories are defined: mutable data types and immutable data types. Mutable data types can be modified after they are defined. It is possible to change the size, like adding a new element into a list or into a set. As mutable data types are designed to be changed, changing does not require a huge computer effort. Thus, changing is cheap. But on the other hand, mutable data types have a disadvantage as they are less quick to access. Immutable data types are data types like Boolean values, integers, float, tuple, strings, or frozen sets. Immutable data types cannot be modified after their definition, so they stay constant typically. The changing process of immutable data types is rather creating a new element. Thus, changing is more expensive in terms of computing efforts. But immutable data types have a huge advantage compared to mutable data types, which is a quicker access to the values stored in the variables. A closer look at the object's memory ID via the Python ID function shows that the memory ID of immutable elements changes after changing the variable values, whereas the memory ID of mutable elements remains constant. The changing of the memory ID indicates that the previous object has been dropped and a new element or object has been created instead. On the right hand of the slide, you see an example provided. In the input cell number 1, 5 elements have been defined. First, a string, afterwards a number, afterwards a list, a tuple, and a dict. In the input cell number 2, the memory address of these objects are printed out by the help of the ID function. In the input cell number 3, the value of this object has been changed. And in input cell number 4, again, the memory ID of the objects have been printed out. Comparing the printed memory IDs from the input cell number 2 and input cell number 4 shows that the memory IDs of the immutable data types have been changed, whereas the memory IDs of mutable data types have remained.
Welcome to Unit 3 on statements. Statements are lines of code that the interpreter can execute. Often statements also contain expressions. These again are lines of code which the interpreter can evaluate to a single value. Now, what are the goals of this video? The first goal is that you get to know how to use assignments and expressions. An assignment is a basic type of statement. This directly connects to Unit 2, where we learned how to initialize variables and assign values to them. But here we will go beyond that and get to know additional assignment operators. The second goal is that you know how to implement important control statements like conditional statements and loops. Without control structures, you won't be able to implement powerful or efficient code. As in many other programming languages, the important keywords are if-else statements and for or while loops. The third goal is that you know how to implement list comprehensions. Comprehensions are a way to construct lists or also tuples or sets from existing ones in just one line of code. This is an example of Python's concise syntax. Now let's start with something that we already know: assignments and expressions. Here in the middle you see a piece of code that you know already from Unit 2. It's about calculating the body mass index from values of age, height and weight. And up here you see the general structure of an assignment. Again, an assignment is one basic type of statement. So typically on the left side you have a variable or a variable name. In the middle you have the assignment operator. Here it's always the equal sign since we are here initializing variables. And on the right side you have an expression. The expression is evaluated first and then assigned to the variable. In Python, any combination of literals, variables and operations that evaluates to a single value is called an expression. And as you see, an expression can also just consist of one number. Further to expressions, like in maths, there are certain rules to follow. For example, the interpreter always would evaluate the exponentiation before the division. This is the same as in maths. The equal sign is the most frequently used assignment operator, so I will note it up here. However, as indicated previously, there are also other assignment operators. For example, there are specific composite assignment operators which in addition initiate a mathematical operation. For example, minus in combination with an equal sign, or a plus in combination with an equal sign. Or you can do the same with multiplication and division, and also with other mathematical operators. Now, what is the syntax of these composite assignment operators? You see an example already here on the right side, but let's first look at the general syntax. So typically, as for the general syntax here above, we have a variable name, then such a composite assignment operator and expression. And this converts to another statement, basically to an extended expression, where the expression on the right side, this one here, is applied to the variable on the left side using the operator. So we have here then a new expression which takes the variable on the left side and applies the expression using the operator. Then the result of this is stored back in the variable. This has direct consequences. For example, that the variable needs to exist already and that its value at the same time will also be changed. So that's not for initializing variables, but it's for variables that have already been initialized. So up here you see an example of converting the calculation of the body mass index to two statements where we have first initialized already the BMI variable with the weight, and then we use such a composite assignment operator to divide it through the squared height. Now you can ask, what is the use case of such composite assignment operator? This is relevant, for example, if you need to increment a variable multiple times in a loop. Think of calculating numerical statistics. So we will later in this video see an example of this. Another point that I want to make here is that typically for providing a BMI, body mass index calculator, we would not want to hard code the values in the program, but we would like to ask the user for input on age, height and weight, for example. And this can be easily done in Python via the so-called import function and a subsequent conversion to the required data type, since the input function always returns a string. So you see an example for obtaining input for the age here in this code piece. For more details on this, please watch the specific shortcast on the input function. In order to implement powerful and efficient code, you typically need control structures. And a basic control structure, an essential one, is a conditional statement which allows you to formulate conditions based on which certain code is executed or not executed. However, before looking into the syntax of conditional statements, we first need to know how we can formulate a condition. And for this, we need to extend our understanding of expressions. Until now, we mostly looked at expressions with numerical operators, which evaluate to a numerical value. We also applied operators to strings, for example, the plus operator to concatenate strings. However, there are also operators based on which expressions are evaluated to a so-called Boolean value, true or false. Compared to what we learned in Unit 1, bool is a new data type which only can take on these two values, true or false. Operators which lead to a Boolean value are called comparison operators, and expressions that use such operators are called Boolean or conditional expressions. And these are the basic ingredients for formulating conditions. Now let's quickly look at the typical, most frequently used comparison operators. Here you see a table. On the left side, typical comparison operators. Here the meaning. And next to it, their usage in a very simple expression comparing variable A and variable B. And here we have some space for ourselves inserting the result. But first let's talk about the comparison operators. So most of them, I bet that you know those from maths, like the greater, greater equal, and so on. But there are also some specific things to remember concerning the symbols. For example, if you want to test two variables for equality, you do not just use one equal sign, but you use two equal signs, like here. Because using one equal sign has already the semantics of initializing or assigning values to variables. So if you want to compare A and B, you need to write the expression A double equal sign B. And also for testing on non-equality, we have the specific combination of an exclamation mark and an equal sign. So, and now let's just quickly go through these operators because I think the other ones are very familiar to you, and write the results. So, assuming that we have a variable A that has the value 5 and a variable B that has the value 8. If we want to test A and B for equality, so evaluate this expression here, since 5 is not equal to 8, here we would receive the result false. Then the opposite, if you want to evaluate for inequality, by definition, we would then obtain here the opposite of false, which is true. Then here, if we evaluate the expression A greater than B, in that case 5 is not greater than 8, this would be false. And also 5 is not equal to 8, so A greater or equal compared to B would also be false. And then A smaller than B would be true, and also A smaller or equal compared to B would be true. So now that we know how to formulate conditions, we can go to conditional statements. First, let's look at the general syntax. So what we see here in color and in bold, so the if keyword and this colon symbol, this is part of the syntax of an if clause. If clause is one possible clause in a conditional statement, and we will see further clauses afterwards. Here in the triangular brackets, these are placeholders for a conditional expression and for statements. The semantics of this if clause is that the statements are only executed if the conditional expression up here is evaluated to true. If it's evaluated to false, then the statements are skipped. Which is very important is that in Python, the statements here need to be indented. A standard indentation is 4 spaces. You can also use other indentations, but what is important is that all lines of code which belong to the statements block here all need to be on the same level of indentation. Now what you see here is also the minimal version of a conditional statement, just one if clause. However, what you can also do is that you can just add further if clauses if you want to test for several conditions. And then what you can also do is to add a so-called else clause. The semantics of the else clause is now that it always refers to a preceding if clause, and the code block, which is indicated here, it's called here default statements. This code block is only executed if the preceding if clause was evaluated to false. So the consequence of this is that the else block doesn't have its own condition because it refers to preceding if clause. And then what you can also do is to insert in between, optionally, elif clauses. Elif is a combination of else and if. An elif clause also refers to a preceding if clause. However, it also in addition checks for a conditional expression. So the semantics here is that this elif clause would be only considered, so only evaluated, if the preceding if clause is evaluated to false, and then the statements here would only be executed if in addition the conditional expression of the elif clause is evaluated to true. And also here you can have more than one elif clauses. or as I mentioned, it's optional, you can also leave it out. The else clause is typically used to implement default statements, to execute default code if none of the previous conditions applied. So this is why this is mentioned here as default statements. But now this is a bit theoretical. Let's look at a simple example. So what we do here is to compare two variables, a and b, and the values for these variables are supposed to be provided by the user. So we use here the input function to obtain values for a and b. Note that here I'm just trusting that the user will input a number. Obviously here errors can happen, but how to handle these, this will be treated later in Unit 5 of this course. For now, let's assume we get actual numbers for a and b. For example, here the user has entered 5 for a and 8 for b. And now we use an if, elif, else construction. So here we test if a is greater than b. If this expression is evaluated to true, then we print out a is greater than b. Elif, so else if a is smaller compared to b, then we print out a is smaller than b. And then we use the else, because if a is not greater or not smaller, it can only be equal to b, then we print out a is equal to b. So what you might also notice here is that we use here the elif clause, but for obtaining the same result, we could also have used an if clause. It would give us the same result of this function if we just crossed out the e and the l here and just use an if clause. To use elif here is only, in that case, a matter of efficiency. Since if the first if statement here was evaluated to true, and we have here only elif and else, the interpreter knows already that it can skip the other remaining parts of the complete conditional statement. If we would use an if clause here, we would come to the same result, but the interpreter would have to evaluate this expression here as well. So this is here, the elif is here for reasons of efficiency. Also, maybe you can think about how the interpreter actually knows that the conditional statement ends. How does the interpreter know that? I mentioned that in other programming languages, we typically have these curly braces to enclose statements that are only conditionally executed. And in Python, it's the indentation. So here, since this statement is now not at the same indentation level compared to the previous one, the interpreter knows that here at this point, the conditional statement ends. And this statement here, the printout, now we are done, is again part of the normal statements in the program. It will be always executed. Besides the conditional statement, another powerful control structure is a loop. In real applications, you will often have to execute a set of instructions multiple times in a row, for example, for each item of a collection. And for this, you can use a for loop. Now in the syntax here, again, the keywords and symbols of the syntax are colored and bold. So for, in, and the colon. And the triangular brackets represent placeholders here for variables and statements. So in Python, you have a very intuitive way to loop over collections. Now you can just write a variable name in and then the name of a collection. The collection can here be a set, it can be a list, or it can be a dictionary or other collections. And then here the interpreter takes care that each element of the collection is accessed exactly once. And in each loop, the variable name takes on one element of the collection, or it holds one element of the collection. And then you can work in the statements block, you can work with the specific item of the collection via the variable name. Internally, this uses so-called iterators. For more details on that, there is also a respective shortcast. Besides looping directly over a collection, you can also loop over other iterables, for example, over a so-called range of numbers. So in Python, the range function accepts 3 arguments. You see the general syntax here. You can generate a range of numbers by specifying the starting number, the stop number, and the step size. Whereas the start is optional and the step size is optional. The start defaults to 0 if it's not given, and the step defaults to 1 if there is no step size given. So to make a short example, if we write something like range of 11, maybe you want to think yourself about what it produces. For that, I have to add a certain detail concerning the range function. The stop number is excluded. It's not inside the range anymore. So range of 11. We didn't give a start index, so it starts with 0, which gives us a range of numbers from 0 to, and since the stop is excluded, to 10. The numbers from 0 to 10, and the step size here would default to 1. So this is another iterable where we could just, which we could just use in this syntax up here. Now, alternatively, if you need to execute statements as long as a certain condition is met, you can, instead of a for loop, you can use a while loop. So here we have the syntax or the keyword while, a colon, and then the conditional expression is evaluated, and as long as that evaluates to true, the statements, the indented statements, are executed. For both types of loops, we have certain keywords that we can use inside the statements block. So inside here, we can use either break as a keyword, or we can use continue as a keyword. And these have a certain semantics. If we use break, it means that the whole loop is stopped. So the interpreter will continue the execution after the loop statement. And the continue keyword just results in the fact that the interpreter will jump to the next loop. So we will later in this video see both types of loops in action. Now there is a last piece of programming theory that I want to share with you before going to the practical part. As we know, Python promotes being concise. And when working with data, let us take, for example, lists of data, you will often have to create new lists, for example, subsets based on certain conditions from existing ones. And for this, Python provides so-called comprehensions, where you can do this in just one line of code. So here you see the general syntax. It doesn't really fit here in one line, but it's only one line of code. Again, the keywords are bold and colored. We see here for, we see in, and we see if. So it's kind of a combination of for loops and conditional statements. And then you see in triangular brackets, again, placeholders for expressions and for variables. And what you also can see here is that we have here the square brackets. And if you for a second forget about the content in here, basically what we are doing is we are having here a list name, so a variable name for a list. And then with these square brackets, we are creating a list. And how this list is created from an existing list, this is defined here via this syntax. The easiest is here actually to start reading from the middle. So here, if we take just this clause for variable name in existing list, this is what we know already from the for loop. Yes, we loop over the elements in an existing list. And then we can write here an expression defining what we want to do with each element. And then in addition, but this is actually optional, we can also formulate a conditional expression to say which elements of the existing list we want to consider. So let's make a short example here on this to see how it works. Let's try to evaluate this example. What comes out of this code? We have a list, and the list is generated from the command range of 11. We saw what this results in previously. It gives us a range of numbers from 0 to 10, and this range is converted to a list using this list command. So now we have the list of numbers from 0 to 10. Just let's write it here. We have 0, and then we have 1, and so on until the 10. And now let's analyze this comprehension here. Let's again start in the middle. For x in my list. So for each element in my list, so for each number between 0 and 10, which elements do we want to consider? This is written here. If x, this is how we access the elements because we wrote it here for x in my list. If x modulo 2 equals 1, this is all odd numbers. So we consider only all odd numbers. Then we want to square the current element and then insert it into a new list. So what this command does is it takes only the odd numbers between 0 and 10, puts them in a new list and squares each element. So we have 1 squared is 1, 3 squared is 9, 5 squared is 25, 7 squared is 49, 9 squared is 81, and that's it. And that's the result of our list comprehension, just in one line of code.
Now let's come to the fun part of this video. Let's come to the practical part. Here I'm showing you a Jupyter notebook that I prepared for testing out some of the concepts like loops and comprehensions. The first code cell shows an implementation of a list containing dictionaries for students. You might remember this from the last unit video of Unit 2, where we got to know different collection types. And here I'm made up some more students. I made up data sets for 5 students. These are not real. This is not based on real persons. It's just invented by me. And for each student, we have a dictionary with the keys matriculation number, degree program, and semester. And then all of these student dictionaries are stored in a list. And the list is our base data set. Let's say it's our Python course that we want to work with. Now, if we, for example, execute this code cell, what we see is the print command. It can directly print the list of dictionaries, and here is the data that is inside, that is stored in this variable Python course. And if we look at it, well, it looks a bit messy. It's not so easy to read. So let's first of all try to present that, write that out in a bit nicer way. So in this next cell here, this is actually a markdown cell. I formulated some tasks. The first tasks are data extraction and analysis using for loops and comprehensions. And the first subtask is to print out the course data, 1 student per line. Just to make this up here, this print out a bit easier to read. So how could we print out the course data so that we get 1 student per line? We know that if we use the print function once, it typically adds a line break at the end. So, and how could we now, for each student in the course data in the list, how could we call the print function? That sounds very much like we need to use a loop. And since we would here loop over a collection, in that case a list, we can nicely use a for loop. So let's do it. Let's start with a for loop. And the syntax here, if you remember, is you have the keyword for. then we have to define a variable based on which we want to access all the elements. So maybe to repeat this again, we want to loop over this variable Python course. So let's call it person, or let's call it maybe student. For student, and then we have the keyword in, and the list over which we want to loop is named Python course. For student in Python course, and then we need the colon. And now we need to indent. This is automatically happening here in JupyterLab. We need to indent the statements that we want to execute for each student in Python course. So what we want to do is to print out the student data in one line. For this, we can just use the print command. And now let's do it by hand. We access all the different keys, all the different entries in the student dictionary, because each item in the list is a dictionary. And the dictionary keys, we can see them up here, how they were defined. So let's first print student, and then how do we access the values of the keys. We use the square brackets, or we could also use the get function, but here we use the square brackets, and then we have to enter the key. Let's first write the matriculation number. So print student, or the value of the key matriculation number in the dictionary, which is stored in student. And then next, we want to print, let's say, the semester. And next, let's print the degree program. So we have a for loop and one statement in the indented block. Let's try this out, how it looks like. And well, you see we have now here nicely one line per student, and it's much better readable compared to what was printed out here above. Okay, first subtask is already solved. So let's look at the second one. Compute the average semester of the participating students. Okay, compute the average semester. So the semester, we can access it via the key semester. This we have already basically prepared. We can just use the for loop. But then if you want to compute the average, how do we do it? We need to sum up all the semesters of all the students and then divide it by the number of students. So for that, what we need is to initialize a variable which we can use to sum up the semesters. So let's call it sum semester and initialize it with 0. And then we can just use the for loop, which is already there, and can inside add another statement, which is also indented. And here, sum semester, here we want to add up the semester of the student, which is stored in the variable student in the current loop or in the current iteration. And if you remember, I mentioned it in the connection with these composite assignment operators. If you need to sum up or increment values variable times, you can nicely use a composite assignment operator. The sum semester variable is already initialized here, so we can here just write plus and equal sign. And then we just have to write on the right side the expression that we want to add to sum semester, and that is in this case student. And then here we want to access the semester. So with this line of code, then we always add the semester number of the current student to sum semester. Then if all students were, if the for loop was executed for all students in the Python course, then we have the sum of all semesters. And then just let's print it out after the loop. So here, if we remove the indentation, Then we indicate to the interpreter that this is the last statement in the loop, and this statement which follows here is again executed every time. So print, let's write print the average semester for the Python course is. And then what we need to do is use our variable with the incremented semesters, some semester, and this we need to divide through the number of students in the course. And how can we access the number of students? With the function len of Python course. So then we need the closing parenthesis. So that should be it. Let's try it. Let's execute the cell. And what do we see? The average semester for the Python course is 1.4. Obviously, we have here only 5 students that are made up in the course. And one thing that you might want to do yourself just for practicing is maybe to change this here, these definitions, to not make up student data sets in the code, but to read them in from a file, and maybe to read more data in. So, but of these 5 students, the average semester is 1.4. Let's go to the last subtask here. Now what we should do is to get a list of matriculation numbers from the data science students. So only the students that have data science as a degree program. We see here there are 4 of them which have data science as a degree program. So we know already how we can access the degree program. We can again use the for loop. There we have already the loop over all the students in a Python course. We can just access the degree program like we have done it here. And then we should put the matriculation numbers of these students, and this is how we can access it. We should put them in a new list. So first thing we need to do is to make up a new list, which is at the beginning empty. Let's call it mat numbers ds. And here we have an empty list. And now we can just add another statement into the for loop. So what we want to do is to write a condition. We first need to check, or we want to consider only these students which have data science as a degree program. So we need a condition. If student, and then we need the value for degree program, equals data science. This is our condition, and here we need a colon. In that case, we want to add the matriculation number of this student to our list. So this we can do with an append. And again, here we need this indentation because we are having here the if clause. And these statements which follow here should just be executed if the conditional expression here is evaluated to true. So then we want to append. And what do we want to append? The matriculation number. So that should be it. And then let's print it out here at the end. The data science students are. And then we can just put here the list. Okay, let's try it. Seems it has worked. The data science students are, and then we have here 4 matriculation numbers. And if you want, you can later on yourself check whether these are the correct ones, but at least we see that we had 4 entries with data science in it. So, and maybe you have yourself spotted already that for solving the last task, we had to generate a new list from an existing list, and we also had to formulate a condition and do this in a for loop. And this sounds actually like something that can be done with comprehensions as well in a bit more concise way. And here I formulated another task where you should use a list comprehension. Get a list of matriculation numbers, and now we have a slightly different condition from all first semester students using a list. So now we have to think shortly about the syntax of comprehensions. Comprehensions generate a new collection. So in that case, we want to generate a list. So then let's make up a variable name for the resulting list. Let's call it first semester. And then a list typically has these square brackets. And now for the syntax of the comprehension, we started to, in the theory part, we started to read that from the middle and basically noticed that we had a for loop statement in there. So let's just copy that from above. For student in Python course. And now to the right, we can formulate a condition if, and then we need a conditional expression. And here our condition is we just want to consider all first semester students. So if student, then the value of semester equals 1. And then in the list comprehension to the left, we can write an expression what we want to do with this entry that fulfills this condition here to the right. We want to put it in a list. So just putting it in a list, we would just have to write the variable itself. However, we want to not put the complete dictionary here in a list, but we want to put the matriculation number in a list. So we need to access the matriculation number. So, and that should be it. That should be that should do the job. That should be the code that gets a list of matriculation numbers from all first semester students using a list comprehension. And let's print it out so that we can also check it. Let's print the first semester students are. And now let's output the generated list. And now we execute the code, and what do we get? The first semester students are, and then we have 3 matriculation numbers starting with 9, 7, and 6. And if we check here, we have 1, 2, 3 first semester students starting here with a 9, with a 7, and with a 6. So that's it, as concise as this. In principle, every for loop can be converted to a while loop. However, there are also situations when while loops are just more suitable. For example, when you do not know in advance how often the loop needs to be run. Now let's look at a coding example where exactly this is the case, and let's apply the concept of while loops. So here our task is to write a program which lets the user guess a secret number. So in the code, I have already defined a secret number. And now we want to, in a loop, request inputs from the user who should guess the secret number. And the loop should be terminated, or the game, it's kind of a game here, should be terminated when the user actually guessed the number. And otherwise, it should ask the user again. So here we have no idea how many tries the user will need. So we use the while loop. And since we do not actually have at the moment the possibility to formulate a condition, we use a construction where we first of all formulate an infinite loop, which we then, given a certain condition, stop using the break keyword. So how do we formulate an infinite loop? What we need to do there is just to formulate a condition which is always true. And this can be easily done by just writing it hard-coded. So we do not put an actual expression here, a conditional expression, but we just write hard-coded the keyword true in here, while true. This is an infinite loop to start with. And then let's ask the user for input. And let's store the input in a number so that we can later on compare it. Let's call it, or let's call it user number. User number equals. And then we know we can use the input function with a clause that will be, or a string that will be presented to the user when asking for input. So please guess my secret number. And we also know that the input function always returns a string, so we need to convert it to an integer using the int cast function. So now we have a number from the user. We need to check now whether this number is already the secret number. So this sounds like a conditional statement using an if clause. If my number equals, or it wasn't my number, it was if the user number equals my secret number, then we need a colon. In that case, we want to congratulate the user. So let's print congratulations, you are right. And at the same time, we can then stop the loop statement because the game is over. Let's also print that out down here. If we leave the loop, let's print out game over. So, but what happens if the user hasn't not yet guessed the secret number? In that case, we need an else clause. And let's then just print sorry, try it again. So let's try it out. Let's execute the code. Please guess my secret number. Let's guess a 1. Sorry, try it again. Please guess my secret number. Let's guess a 2. Sorry, try it again. Let's try the 3. Oh, well, yes. 3 was the secret number. Congratulations, you're right. And game over. So this was a nice use case for a while loop, and actually for an infinite while loop, where we also saw how we could use the keyword break. Now, as a learning control and to develop your programming skills, you can just try, for example, to extend these coding examples. You might, for example, take the Python course coding example and convert a for loop to a while loop. Or what you could do, for example, is to make the game a little bit more interesting, and you might give the user hints based on his or her input to find the secret number more quickly. For example, you could give hints whether the current guess is smaller or greater than the secret number. You can just be creative here. Just be creative and have fun. Hope to see you in the next video.
Introduction to Unit 3 Statements. This video introduces Unit 3 of the course. Important topics of the videos for Unit 3 are assignment operators. With assignment operators, the values stored in variables can be set or modified. So we will gain an overview of common assignment operators available in Python. Input function. The input function is shown in this video. It enables you to take user inputs into the program operation. Boolean values and the type function. The Boolean data type and the type function are shown in this video. The latter enables you